Hey, what's up, folks? Welcome back to another 3D Hangouts. My name is Noel Ruiz. I'm a designer here at Adafruit. Joining me every week, my brother Pedro.
Good morning, everybody. Pedro Ross Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
Yes. This is the show where we combine 3D printing and DIY electronics, smash them together to make inspirational projects. Hello, everybody. Welcome to the show. This is episode 490, and it's July 9th, 2025. Hello, everybody. We're hanging out in the Adafruit Discord server. Where are you? There you are. If you'd like to join us throughout the show, you can drop us a comment on the Adafruit Discord server or on any of the social networks. We're streaming on Facebook, LinkedIn, YouTube, Twitch, and X. We'll take a moment to let folks come in on all the streams. If you got any questions, we can bring them into the show, and if you got any gifs and memes, we can show those as well in the Adafruit Discord server. We're back this week, folks. We got a new project. We got a prototyping thing that Pedro's been prototyping. I think we have a shop talk. I got some new CAD parts. I got a lot of CAD parts that I'm working on. And I think we have a time lapse as well. And I think one community make. All that and more on 3D Hangouts. Let me kick it off with adafruit.com/free. And a coupon at the end of this segment. If your order is $99, if you buy stuff at Adafruit and your order happens to be $99 or more, you're going to get a free PCB coaster with a golden Adafruit logo. If your order is $149 or more, you'll get that PCB coaster plus an Adafruit KB2040 free. And at the top tier, tippy to top at $199 or more, you get free UPS ground shipping, continental US only, as well as the KB2040 and the PCB coaster. All that gets automatically added to your cart. And while you're at checkout, why not use our coupon code THERMAL to get 10% off your order? That's right, THERMAL. It's a coupon code, special code just for the folks watching. That includes all of you. We appreciate your orders, and THERMAL. It's good for the next 24 hours. Whee! All right. I want to give some shout outs to the lovely folks joining in on the Adafruit Discord server, starting off with squid.jpg. Good morning. We got Dew Wester. Hello. And Dan Mitchell. Hey there. On YouTube, we got Kinger North saying hello. Thanks for joining us. All right. This week's project. What do we got? This week, it's my week. It's a collab project with Liz Klush, of course. She put together the Python code for this one. Let me bring up my screen. Woo, it's a Raspberry Pi with 2 cameras? No way. So this project was inspired by a project called Pit Fusion. And the idea here is we have a Raspberry Pi, and then we have 2 cameras. One is the camera from the Raspberry Pi. It's the version 3. And then we have the MLX IR thermal camera. So the idea is that you can do something.
Fusion.
Yeah, where you can combine those and you have an overlay image on top of the camera's image. So let me switch my screen. So this is a really nice case. I designed it. It's the Raspberry Pi 4. We didn't want to use the Raspberry Pi 5 because there's some extra stuff that you got to do for it. But the Raspberry Pi 4 is pretty accessible and a little bit cheaper. We don't need all that power, that processing power. But it's a snap fit case. It has a tripod mount, and it's this is the first Raspberry Pi project where I did some multicolor. So you can notice here that we got some really nice colors going on. These aren't snap fit parts here in this top part. It's all one piece with multiple colors. And
Nice.
I got the
EMS. I'm so used to it. It didn't even come to mind.
It didn't even come to mind. Yeah.
Yeah. So wow, we're finally at that level.
Yeah, we can make some really cool stuff where you can like just create some more like.
Maybe give it a second thought. Wow.
Yeah, it's pretty cool. So
very cool.
Let's take a look at this one. Yeah. Ooh. Yep. So this is the Raspberry Pi thermal overlay. This is all done using Pillow and Blinka. Blinka is, of course, is the Raspberry Pi Python compatibility layer for our CircuitPython libraries. So this is using the MLX. I think it's the 90640 IR camera. So you can see here that is my face because the camera is pointing at my face. And the IR image is overlaid on the Raspberry Pi image. So let me back up a bit so you can see. I've got a really hot face. And it looks pretty cool. You got some slow frame rate because it's doing a lot of processing, but you can see here there's some text overlays. Gives you the range of the temperatures, an average range, the maximum, the minimum, and the opacity, and kind of the color level there. I've got my coffee mug here. Let's see how hot it is. It is red hot, very, very hot. Be careful. It's very hot. So yeah, this is pretty cool. Thermal imaging camera. We have a toolbar at the top here that allows you to change the opacity, the minimum and the maximum range of the image. And you can also do things like zoom in, zoom out, and you can save images and capture images as well. Yeah. So again,
can you do zero opacity to see the image?
Yeah, you can. Yeah, I've got my external keyboard here. So let me make sure I click on there it is. You can see my mouse moving. And then I think it's the minus key is a hot. We also have hotkeys, so you can use your arrow keys and the plus and the minus key. So you can see here this 0.4.
Oh, wow.
0.3, 0.2, 0.1, and 0. There's my face.
Cool.
Yeah. So there's my coffee mug again. Yeah, it's a little blurry because like I'm not in the frame or whatever, but that's fine. There you can see. And the IR is only the IR sensor breakout can only do like I think 64 pixels by something. So we have to do like some extra image pixel doubling to get this to work. But it's a proof of concept, if anything. It shows that you can get it done, and it's all done again with Blinka because you can use CircuitPython libraries on your Raspberry Pi. And connecting all this, there was really no soldering also, so it's an easy project to quickly put together if you want to prototype something like this, which we'll take a look at. I guess now I just got to switch my screen share away from the capture card, which is how I'm able to do bringing in the HDMI feed from the Raspberry Pi into our StreamYard. We're using a little Elgato HDMI to
After the
USB-C
show
thing.
Looks like you have an update for the Pi. Maybe that'll break it or make it faster.
I think it's up to date, to be honest. Yeah. All right. Let me bring in the web. All right.
Last time I updated, it broke my touch screen. I was like,
no, did it? Yeah, that's one of those things. All right. So overview of the Learn Guide is here. Do you want to put a link to the chats, Pedro, while I kind of walk through the parts? So yeah, big shout out to the Pit Fusion team for putting together this. You can purchase this, I believe, this all-in-one PCB that takes the IR, the MLX90640 IR thermal camera and the Raspberry Pi camera module and puts it in one PCB. They also have their own software, which shows this pretty good demo of like putting it on a 3D printer so you can kind of track your build, your bed plate, and see how hot it is, and maybe give you alerts or something when it's cooled down or too hot or something. So it's all open source, which is really cool. So check that out if you are interested in getting like an all-in-one solution. So we're inspired to, kind of just do a prototype version. So again, we have the MLX90640. It's 24 by 32 pixel IR thermal camera breakout. It's pretty cool. And then, of course, the Raspberry Pi camera module 3, the standard lens, not the wide angle lens, just the standard lens. And the Raspberry Pi 4. And then this beautiful piece of tech here. This allows us to just plug in StemmaQT stuff, EYESPI stuff. It has built-in on-off switch and a couple buttons. And it just plugs right into the GPIO header pins. No solder needed. Just plug it in. It's all assembled and ready to go. So this was my first time using. It's called a Raspberry Pi Beret. A Beret. And it just makes it easy to connect. Yeah. It makes it easy to connect the STEMMAQT breakouts to your Raspberry Pi. And this is really great. And here in the photo, you can see it. It's got a magtometer plugged in and also an e-ink display. So that's a really cool way to kind of do like a plug and play situation with your Raspberry Pi, because normally you have to kind of use header pins or something and like connect them all up. But this is really nice. This is the first project that we're using it. Look at that at the bottom here. So really good. I made a 3D model of it. So if folks want to use it in their projects, take a look. It's a really good solution for connecting things to your Raspberry Pi. Of course, you need some cables. Of course, we got the STEMMAQT cable. This is the micro HDMI, because the Raspberry Pi 4 has a micro HDMI. Power supply, some tripod screws and things, and then some hardware to attach the things to the 3D prints. Even though it snap fits, you always want to have some screws to make it really nice and secure. To the circuit diagram, pretty simple, no soldering. Again, we're just connecting things together with cables, but that's there if folks need it. For the 3D model, there's just 4 parts. You got the top and the bottom half of the enclosure, and then we have the optional parts that have a little stand and a little kind of, what would I call it? I guess a connector bit, a mounting bit for the tripod screw. So I like to kind of break out the tripod adapter so that it's no soldering or no support materials required, and you just attach it with some screws. So for the top cover, I have 2 versions of it, right? I got the multicolored part that has up to it's 4 colors, right? 1, 2, no, it's 3 to count. So the top cover can be printed in those 3 colors. You can choose. There's a 3MF file that has all that color data already separated for you. That's what I love about 3MF files. And so we've moved away from STLs, is that 3MF has that extra metadata where you can have an object have multiple parts in it, and then you can select what colors you want on your slicer. So whether you're using the Prusa MMU or the Bamboo Labs MMU, the 3MF should be supported. Also, of course, I have a single color version. It's in the title of the 3MF. I think it's top cover single color is what I call it. So you have the option there, and then you can see here.
I think it would both work. It would just load up as a single color.
Right, yeah. So here is a quick screenshot of how the objects are sorted. I even named them properly. So you can see here under the top multicolor 3MF, there's the internal plate, lens A, lens B, and then top cover, which is like the outside shell of the top cover. And that works pretty well. I use default settings, I think, for my purge tower. I'm sure you can optimize those, but I kind of stay. I think I lowered the
updated firmware. Yeah, they have updated stuff for the firmware, so I just leave it now. I don't even do the flush.
Oh, really? Yeah, I figured that's like, I know they're constantly improving it.
Yep.
I finally updated my firmware over the weekend, and the interface is so much better on my Bamboo Labs. I just feel like it's like a lot easier now.
Yeah,
which I love to see updates that are actually good and useful. But I pushed it off for maybe 3 weeks or so, but I finally did it, and yeah, it's all good. So yeah, we have 3MF files, and of course a step file, an open step file. You can bring that into whatever CAD package supports step, which is a lot. And then of course the Fusion 360 file, which has all the things. Here's a quick screenshot of all the parts. You got the Raspberry Pi camera, the Pi 4, which I got those from GrabCAD. That's where I like to get my non-Adafruit 3D models. I go to GrabCAD or DigiKey. They have a lot of parts as well that are 3D models. But yeah, there's the EYESPI Beret. I
think it's Beret.
Beret. And the MLX90640 thermal camera breakout is there as well. Yeah, this was fun. All right, on to setting up your virtual environment in your Python virtual environment for your Raspberry Pi. This page here walks you through all that. If you haven't done that before, pretty straightforward because it's all documented there. So we set that up, and then on to installing Blinka, the compatibility layer for CircuitPython libraries running on a Raspberry Pi. This walks you through all the steps. You got to do it because it's Linux. And then after that, we can install the thermal camera software. Thank you, Liz, for putting together this project. This code. It breaks down how to install it with a pip install. It's using OpenCV, which is a great library, and of course the CircuitPython library for the MLX90640. So here's all the code. It's got comments. It's got customizable parameters like the window size and the window size, width and height, the camera width and height, and all that stuff. The zoom, if you want to do zoom stuff, it's all there. You can change the color map if you want as well. We tend to stick with some standard colors, right? Red is hot, blue is cold, but you can change that to however it wants. And a little bit of how the code works here as well. On to the assembly, pretty straightforward. We're just plugging things in the right order, of course. Optional tripod screw. Love having a little 3/8 to quarter 20 inserts. Installing the tripod mount to the back cover. You'll want to do that before installing the Pi, because once you do, you can't get to it. But anyway, the Raspberry Pi just fits in with all the portholes nicely lined up. And then I'm just using 2 screws to secure it to those standoffs. And then the Raspberry Pi camera has different mounting holes than the MLX. So it's hard to get it wrong, right? So you just kind of orient it the right way and secure it down with some M2 screws and then M25 screws for the MLX90640. So they're right up next to each other. Of course, you want to make sure to take note of where the STEM QT cable is. Obviously, maybe it's not so obvious. You can see that there's 2 STEM QT ports on the breakout. You just want to use the one on the far left facing this way. So that because it's right up against the PCBs are pretty much touching with like 0.2 millimeters of clearance. Because that was the closest I could get those PCBs together, and they're oriented upright. So that's all sorted for you. The brake just gets fitted on top of the GPIO. Good. And then the only thing is you got to be careful with the ribbon cable. Just kind of finesse it, adjust it so that it's not being pinched or kinked. And it tends to work out. There's plenty of space in there for the cable. Intentionally, there's enough space in there for the cable to hang out. And then last things are connecting the SD card. I think I have a note here. It's just like, hey, make sure that micro SD card is not in the Pi's card slot before fitting it into the case. You ever do that? I think the early days, I remember installing a Raspberry Pi, like forcing it into a enclosure and then snapping. Yeah, all been there years ago.
Yeah.
So it's always good to take your card out before fitting it into a case.
Just in case.
Yeah. But in any manner, I have a little notch out there with plenty of clearance and a little bit of a lip to guard the SD card from like fitting in. Remember when we were learning how to make enclosures and you wouldn't put that lip and you would lose your SD card sometimes? Mm-hmm. Yeah. So it's got a lip in there so that won't happen. Learned a lot in the past 10 years on how to make an enclosure. And then you can install it to the base if you want. The base is just a nice kind of little thing here to elevate the thing. You could also put a, like I have here, you can put a socket head, which I have linked. Nope, that's the wrong one. You could put one of these socket heads here so you can adjust the angle any way you want. Turn it that way, turn it this way. And then, of course, I have a hole here as well that allows it to have the cable route through there. It's just a little bit of cable management. Could have done it for this one, but didn't need to. I love this USB-C cable so much because look at this. And not only does it swivel, it also rotates like that. So you want whatever angle, it works great. Love this thing.
Kids notice that when you try to charge your iPad with it, for whatever reason, the iPad stops charging with it. Yeah.
You're kidding.
No, man.
That's awful.
I know they both mentioned that. So I thought it was
bad
in case somebody wants to buy it just for their iPad.
Oh, okay. That's weird. Maybe it doesn't have like the circuitry or something.
Crying. No, my iPad's dead.
Oh, and you
try to use the freaking iPad. You know how they have whatever.
That's wild.
Crap on their thing. It like shut it off from charging.
Yeah, I've only used it
my
for
other stuff charged fine though.
Right? Okay. Yeah, I have a battery bank that I've charged with it, but I have not used it with iOS stuff yet. Do you think it does the same with the iPhone? I don't know. I don't know, but it's powering this Raspberry Pi, no problem.
It
It's the
charged
Raspberry Pi 4.
my glasses case just fine.
Okay, yeah. So I guess Apple has the iPad specifically, they have some weird,
Man.
they have
Yeah.
some weird things going on.
Yeah.
Yep. I don't know. Another thing I did different was I added a little bit of curvature to the mating faces. I've seen other folks do this with Raspberry Pi cases where they instead of just having this thing go all the way down across, like
Nice.
just flush, I have this little kind of curve
adds to the design.
Yeah, that's the design, but it also makes it so that it has a little bit better grip because I have a lip here as well that mates with it pretty well. So that's pretty good.
Notice that
of course you got to have some. I can feel the heat coming off of here. I don't have an active cooling fan, but it doesn't get as hot as like the Pi 5. So just add some ventilation if you ever make a Raspberry Pi case. Of course you can have ventilation, and I can feel a little bit of heat coming off here. What else?
I want to quick mention, I was grabbing the stemma cables since it looks like we finally got the 50s and the 100s in stock, but we also have a new breakout for the Pi where it's just the stemma breakout. Since that's what you're using the Beret for, right? Just the stemma.
That's right. Yeah.
This might be another way to go. I'm sure it's going to be cheaper since it's just the little. Yeah, it's $2, $2.50 for the just the stemma to add that to the headers on a Pi. Looks like it's coming soon, so maybe by this afternoon. You go to.
Oh wow, I see it here. Let me pull it up.
So that might be a different avenue to go for that component.
Yeah, I'm sure it'll just work. Like, there's no need for the case to be updated. It's the same.
No. I'm just saying for the component. If the stemma is the only thing that that Beret was being used for.
That's so cool. Yeah, this is brand spanking new. Like, it just landed. That's a great idea. Yeah, because the Beret has a little bit of extra stuff. Oh, this would have worked perfect.
I like how tiny it is.
It is. Yeah.
I remember we have. I think it's from SparkFun. We actually have something that's similar to this.
Yeah, the thing with the SparkFun one is it doesn't have a socket header. You have to solder it, I think. Sparkle.
Number.
Here, I'll pull it up. Yeah, it's called like this is it. The shim.
Oh yeah.
Yeah, it doesn't have the it doesn't have a socket header. So you have to like solder
the same price. Ours is
yeah.
I have to say
Ours is better. I said it. Sorry.
You gotta call it how it is.
Yeah. But it's cool. You might already have it. This has been out for a while. Yeah. Actually, we bought one in 2021.
Yeah. I forget what we used it for. Scroll down. What did we use that on?
Nothing.
Oh.
Nothing yet. Now we won't have to. Yeah. Now I like the socket header. No soldering required then. This side face down. Nice. Oops. And has a mounting hole. Who doesn't love a mounting hole? Cool. Good stuff. All right. That's this week's project. Pretty cool use of a thermal imaging camera and the Raspberry Pi camera.
Very cool.
Also, I think it's just a cool case. Yeah.
Yeah. We were saying it looks like that one robot from Fantastic Four. I forget. The one making cookies.
His name is Fantastic. Yeah. Yeah, I really liked doing multiple color stuff, especially when it brings like attention to a different piece of the case. So it just adds so much dimension to the case. Yeah. So I'm all for implementing more multicolored stuff to our 3D printed enclosures.
Super cool.
And it's unfortunately, you can't kind of do that. Like if I wanted to send this off to JLC to get it printed in resin.
Yeah, true.
Multicolors yet. Maybe you can. No, I don't know. But from what I've seen and what I've ordered, yeah. But super cool that a lot of people have access to multicolor stuff now.
Yup.
Yeah.
Super, super cool.
Cool.
All right.
Let me check in on the chats. Anybody got any questions?
It's quiet out here. Noodle Booster would be a great name for a nerdcore band. That'll be for a second here for this Noodle booster.
Noodle booster.
Which we were saying before. We're surprised that's not what the product name for this is.
The code name is Noodle Boost.
Yeah. Let's go ahead and jump into this week's. What are we prototyping? We got this constant current. Whoa. Focus. This little booster board for the LED noodles. And we got on here, it's 2 terminals, one that connects to your JST connection, so you can hook up a little LiPo battery, and then the other end hooks up to your noodles. And we have this connected with the little ends here. This is the single strand noodle. So on each side, instead of having it loop back in, these have the ends, which is my left and right hand. We have them connected to just one end here. So the little side that has a little hole punched out of it is the anode or the positive side, and then the other side is the negative. And you can have a little bit more freedom with your designs for this, so it doesn't have to loop back in. Definitely handy. And these just plug into the out of the little terminal block here. So it's it's blinking on and off because of the way that this connect. I need to solder on some wires so that the connection stays current, pun intended. And then just have a little designed case here. It just houses the little board. So we have a little snap fit, and unfortunately, I'm gonna have to use these this little guy here to plug to sort of open this guy up. And on the inside here, we have the little case. You can see how that is connected up. It's just a press fit design. I need to put like a hole on the bottom here so you can easily push this out of the way.
Sure.
That's all it's doing here.
You
got your little label on the sides here to denote your positive and negative. And here you can see how that is sort of being squished in there to hold on. So I'll have to solder on some more stable wire to have it not blink on and off like that. The other thing you can do with this board is if you need, we have other noodles that are like 24 volts, so you can adjust that with these little jumpers on the side here. So you can go up to, I think it's like 250 for the out, or yeah, 250. So nice little simple board for helping to power your LED nudes.
Yeah.
And this here, it's pretty sensitive since the connections are like paper thin, so be careful with those. And you got the product page here. Here's what they look like. The longer ones, of course, are going to require more power.
Yeah, because you're getting brighter when you flip the switches here. And then the silk screen has some values here of the resistors, so you can use whatever value works for your noodle. And then here you can see the letters. They're all soldered together with wires, and then these two alligator clip, crocodile clip wires go into the screw block terminals.
Yes.
Yeah, I got one. I haven't played with it yet, so this is great. I'm going to start playing with it to make like a new lamp or something with it. Yep. And then your noodle is like a single-ended noodle, right? I haven't played with those either. Do you know what the single end? Here it is.
Yeah, 6152 is one of them.
So you can see here they're very thin. It's almost like the copper tape, like paper phenolic or something.
So thin.
Not the best, but that's what they are. We don't make these.
How small they are.
Yeah. So interesting. You can see how they get chewed up instantly because you get this, and then you got to be careful not to completely destroy your thing. So soldering, I guess, wires. Have you tried soldering to it? Is it kind of tricky?
I'm going to. Because I got to figure out how to keep those two ends separated as well, so they're not touching.
Some heat shrink tubing, I guess.
Although it's so tiny, yeah.
we have small heat shrink.
No, that'll definitely work.
Kapton tape. Could always use Kapton tape.
No, the shrink tube should work.
Okay. Yeah, and it seems like they're long enough to insert into the screw block terminal and also solder to.
Yeah.
Yeah, there's a nice data sheet as well.
Yep.
Which gives you what diameter?
Yeah. So I'm
and
not going to recommend
resistance.
doing it straight ender just because of how the ends get chewed up, and as you can see, it's flickering on and off. So
right, it's a
definitely.
prototype, so it's good to test to see how quickly can I. You could do a quick test just to see if it how well it lights up and maybe play around with the values. Have you played around with the values yet?
Not these, no.
So the
I did
default.
try increasing it. No, this is default, and as it says on the product page, it adds 25 to the or 20. Look at the product page to whatever the current is. I think the default's 20 or 25.
Yeah.
Let's see. Let's try inserting this. I think it's pink. What is this? Yeah, pink one. See, that's the other difficult part of it too. I'm trying to keep these separate. He's inserting there. Oh, you can see it lighten up. Oh, I can't.
Yeah.
A little bit.
There's one hole in one of them that denotes that it's the positive terminal, the positive lead. The anode has a hole.
We attach this guy. There you
go. Hey, I thought it looks pretty.
Wow, yeah, the pink looks super cool.
Wow, it's so great that you can power this Noodle with a 3.7 volt battery because the booster is a boosting.
A little tiny battery. We're using the 100 milliamp. That is perfect for this.
Yeah.
Can you do multiples? I think so. Let's go ahead and test it out. You should be able to. Let's see.
Yeah, I don't know. I haven't played with this board, so again, it's the TPS 116 something TPS. Let me drop in the link for folks.
I think they're out of stock right now.
Indeed. You're asking for too much current.
Maybe.
Yeah.
It feels like the pink's in there good.
I saw it like switch from pink to blue.
Mm-hmm.
Yeah, probably not.
Yeah, maybe not.
It's a question for tonight's engineering show. Yeah, they're out of stock. Yeah.
Perhaps it cannot.
Perhaps not.
Yeah, because it feels like the pink's in there good.
Yeah. One noodle at a time.
Oh.
Or maybe you can like daisy chain the noodle with a wire and then add some wiring to it. You know what I mean?
Either that or use the terminal on here to give it more power. But I'm not going
to. Right. You need to give it more power. That's it. You need to flip one of those switches.
Yeah.
Probably can. You just need a better solid wire connection because look at that. Just kind of flaky. It's really
the ends are like paper thin, like tissue paper thin.
It's like paper phenolic or something. Yeah, or copper tape. I don't know, something. Yeah. So
so the wire to it. It's going to be I forget what the sign was for that movie coming out.
Yeah, cyberpunk sign.
Yeah.
All right. Well, let's take a look again at the product page. There, of course, you can see multiple LED letters that are powered, so that'll be a fun one to try as well. A bit of soldering required for that one, of course. Check out the Learn Guide, which I think is live for more technical details on it. You can get up to 40 volts with the boost. So that's cool. 40 volts is a lot. So you can power both 5 volts or 12 volt noodles, which we have. Just give it 3 to 5 volts on the in, and you can power a bunch of LEDs consistently, because that's the name of the game. Yeah, I haven't even looked at the Learn Guide, but it's all here. All the data's here for you.
Yeah. I do it live, but I gotta like remove the little tiny piece of Kapton tape that's in front of where the power adjuster thing is.
Yeah, here's the dip switch. Here's all the details on the dip switch.
Let's see if I can get to it.
And then there's a PWM pin as well. So you can do some dimming of the LEDs with a microcontroller. So that's cool.
No, I can't do it. I did it with the other one. I definitely need tweezers to remove that little piece of Kapton tape to adjust the voltage on it.
Yep. Here's some diagrams to show you how to do stuff. Here's LEDs in series. Ideally, you want to do it in series, I guess, huh? Like here's the example is the letters, which is cool.
Nice.
All right, so check that out, folks. And of course, I have a 3D model ready for folks, which you used in your case.
Yes.
Captain, I'm giving her all she's got. It doesn't go figure.
I need tweezers to get to it.
Yeah, you do. You can see it on the product page as well. They're using tweezers to flip those switches. This is the tiniest of switches. All right, cool. Well, next week we'll have a little 3D printed case for this, and maybe we'll have these in stock as well. Cool. If anyone wants to pick up some LED noodles, use our coupon code thermal. We'll get you 10% off.
Awesome.
Okay.
Did you post on the blog post where these were used in the latest for a costume?
I don't think so. Maybe that's next week's blog post, but I wouldn't talk about it. It might be not talk aboutable. Vince is saying you could theoretically, how many nodes you can drive with an Arduino? You can use PWM driver, or would the power draw be too much? That's a good question for tonight's Ask Engineer show. And then Squid.jp, because they answered with, in theory, you could drive as many noodles as you have GPIO capable of PWM. We'd have to keep an eye on the power draw, but you should be able to drive quite a few. I've got a project that runs 6 from a Cutie Pie. Yeah, I think I'm running 6 on a Cutie Pie as well. The smaller noodles, though. Yep. Okay. Good stuff. Thanks, folks.
Jump into this week's community makes.
1 second before we do, just want to talk about the Adafruit CAD parts.
Let's do that. I gotta go to the bathroom real quick.
Very good. Go to the bathroom. So folks that have been adding part requests, thank you so much. I've been going through the backlog and adding CAD parts as I get to them. So this week we have a couple parts. Let's check out the commits. This week we have an older USB LiPoly charger. We have a BFF CAN bus. We have a VCNL 4020 sensor and the alphanumeric backpack with Stemma QT. All those have been added, and their 3D models are available in different file formats, including 3MF, STEP, and Fusion 360. And then in case I missed it last week, we also have the TPS 61169 constant current. That's the Noodle boost thing we've been talking about. So there's a 3D model of that. We also have a magnetic sensor. That's the new AS5600 magnetic sensor, rather. And then we also have the BME 688 temperature humidity sensor added as well. And you can check out all the commits. You can subscribe as well to the GitHub repo to find out when things get added. And feel free to add parts via the Issues tab. Again, thank you, folks, for adding stuff. I'll be working on these later this week. We're trying to get into the habit of adding new models as the products are being developed. So this week we have the triple LED matrix bonnet that I need to work on, the simple soil moisture sensor, and then there's some new ones that were added, I think, yesterday. So the M4 CAN Express feather, the BQ25185, that's the USB solar charger, and then the ideal diode breakout, which is going to be added. So I am working on those.
Awesome.
And that is this week's Shop Talk. There you go. Yep, the code is thermal. 10% off thermal. Good for the next 24 hours. All right. Are we ready for a time lapse?
Yes. This week's community makes for Time Lapse Tuesday. We noticed that all the stores are starting to get their Halloween gear out, so we thought we'd get ready with this little skeleton from Minecraft.
Spooky.
So
multi-parts.
Multi-part. All of the body parts snap in together.
Cool.
It looked like it was a print in place for all of it, but you can see why it is not. We're using the marble filament here, and it kind of looks kind of cool and marble, but I'm using the glow-in-the-dark one here. The marble from everyone was not good.
Oh no!
Like every time I would snap in the body parts, it would like break, and tried like increasing the wall count and the infill, and it still kept breaking on me. So I'm gonna try the Polymaker marble one to see how good that one is. If you go over to the screen here, I'm just using the glow-in-the-dark one.
Yeah, light her up.
I didn't grab the purple light. It doesn't look that good on the screen anyway. And oh man, let me disconnect this LED.
The focus rather.
So good articulation on the limbs here. The arms can rotate, and then you got your little elbow here that articulates, and then the little feet down here allow you to have it sit down. There are like little dark spots for his mouth and eyes, but I didn't print it out. But yeah, nice little simple way to get ready for Halloween.
Like a big one.
Skeleton. Well, skeletons for Minecraft.
So those are ball joints, you think?
These are not ball joints. They are, if I could pop this out, it's just a little cylinder that pops into place.
Okay.
So super simple. They rotate too.
Interesting.
Okay. So posable. Comment. You'd be a goner if that was a real Minecraft skeleton. I think the only thing that the kid said was inaccurate was the rib cage.
Inaccurate. That's funny. All right. Well, this is a free model on Maker World, put up by Spennolio. I believe that's how they pronounce their username, but they put that up here. Here it is with the dual extruded face. See the eyes and mouth, that darker color. You can make ninja poses, and it's also keychain.
Oh yeah.
There's a keychain version, I believe. Yeah. Cool. Articulated Minecraft, 13 points of movement. The keychain version was added, I think last week. Here's a breakdown. You can do PLA or PETG. Designed for non-AMS printing as well. Click fit joints. I've never heard that before. And here's some photos of makes and stuff. Okay, cool. All right, folks, check that out. Cool. All right. There's only one community to make this week that we got posted up. I think I missed it, but this was posted a couple months ago, if not a year ago. But this week we got a triple USB foot switch. It takes the original Trinket foot switch and adds like 3 of them in this arrangement here, and they're all kind of daisy chained together in the photo. But this is posted up by Treehouse on printables.com. It says it's a remix of Adafruit's USB foot switch with a triple base. And it's a classic USB foot switch controller project using the Trinket M0. We have updated this project, of course, with the Cutie Pi. And you also made a version with 3, I think, after this was made. Yeah, this was posted up 3 years ago. But somehow I found this because somebody was asking. Remember, Fusion 360 share links broke, and this was one of those. So I went ahead and updated the link and also published the step in Fusion 360 model. So yeah, classic project. Got a little bit of an update. Cool. All right, and that's pretty much this week's show. don't forget, folks, coupon code before we leave, thermal, gets you 10% off your order. We got all those freebies as well. Yeah, kind of short and late this week, but yeah, next week, we'll have the 3D printed case for the Noodle Boost board and maybe some other stuff that I'm working on. Later tonight, we got Show and Tell and Ask an Engineer. We hope to see you then. 7:30 p.m. Eastern Time is for the Show and Tell. I think it's normal hosting, but things have been changing crazy, so everything's tentative now. And then hopefully Ask an Engineer starts at 8 p.m. Tomorrow is JP's workshop, so you can tune into JP. And then Friday is a deep dive with Foamy Guy. All right. I'm trying to. There it is. All right, folks. We'll see you next week. But until then, remember to make
a great day.
Bye, folks. And bye.